have a go through the last one. Now, we're trying to graph y is equal to negative f of negative x. So this is combining both of the two examples from transformations from before. So let's have a look at what happens here. So I'm going to go to my graph. I'm going to get rid of this one here. I'm going to add in a new one. So we want y is equal to negative f of negative x. Okay. This one's a little bit trickier. This one's a little bit trickier to describe. What have we actually done here? Well, let's have a think about it. Now, we've actually applied both those transformations. So what you can see is if we turn on our first transformation, we had y is equal to f of negative x. So we have that green graph, which is y is equal to negative f of x. F of negative x. So we reflected it along the y-axis. And then once we've gone that graph, we've then flipped it and rotated it, reflected it along the x-axis. The other way you can think of it is also we've taken our negative f of x, so the flipped along the x-axis version. We've taken that, and then once we've done that, then we flipped it along the x-axis. Now, both of those are very valid ways of thinking about it. But if we want to describe this transformation in one go, how would we describe it? Now, it's quite difficult to see, but if we rotated this graph along at 0, so if we rotated it around, unfortunately, I don't have the capabilities to do that. If we rotated it, our function at the origin by 180 degrees, you'll notice that we actually get the exact same graph. So here, we've actually rotated the graph at the origin by 180 degrees. So here, this is a rotation about the origin of 180 degrees. So if we want to rotate a function 180 degrees around the origin, we replace both x with negative x and y with negative y. So here, y is equal to negative f of negative x. Ooh, a little bit tricky. Now, this is something that we've actually looked at before. It's a little bit tricky, but we've looked at odd functions before. So odd functions told me that if a function and its rotation at the origin by 180 is the same, it's an odd function. Algebraically, what we wrote down earlier this year was if negative f of x is equal to f of negative x, then the function is odd. Now, this isn't quite the same as this thing over here, but if you just rearranged it a bit, so if I rearranged this and moved, so over here, I have my negative f of x is equal to f of negative x. If I move this minus sign to the other side by dividing by minus 1, I just get f of x is equal to negative f of negative x. So here, an odd function is a function where it has rotational symmetry about the origin by 180 degrees. So if I can rotate my function at the origin by 180 degrees, I get the same one. That is an odd function. A bit of recall back to earlier this year. Now I'm going to go through one example here. So for this function, we want to sketch f of x and negative f of negative f of negative x. So we want to sketch the original function and its rotation about the origin by 180 degrees. So here, let's have a look. We want to sketch f of x is equal to x squared minus 2x. Okay, I'm going to quickly go through that. Now here, this one's quite easily factorizable. So f of x, I can factorize out an x from both the terms. And so here I can get my two x-intercepts. So I've got x-intercepts at 1 and at 0 and 2. Before we do that, we should probably go the the leading coefficient, or the leading coefficient is greater than 0. So the x squared coefficient is greater than 0. So it's a concave up graph. And then we've also got the final thing, if we're factorizing, is we need to find the vertex. Now the vertex is at the middle point between the two x-intercepts. So if my two x-intercepts are 0 and 2, the middle point is going to be 1. I substitute 1 into my equation, I get minus 1. Okay, I sped through that quite quickly, but you can probably do that a little bit slower. That's okay. Okay, I'm going to sketch this graph. Oh, that is terrible as a y-axis. Okay, here we go. Now I have my two x-intercepts at 0 and 2. I'm going to use one unit for each. And I've got a vertex at 1, -1 over here. So let me sketch all this information in one go. Ooh. So this is my y is equal to x squared minus 2x graph. Okay, this is 1 minus 1. Now, what we want to do is if we want to sketch this here, if we want to sketch y is equal to negative f of negative x, we want to rotate this 180 degrees about the origin. You might be like, oh, I don't actually quite see how to do that immediately. And sometimes when I do these types of questions, it's not that easy to see. Not that easy to see immediately. But there's a few steps that you can do in order to get there. Now, if you remember what I showed you earlier when I had this graph up, is that we notice that we can do one transformation first. So we can reflect it about the x-axis or the y-axis first, and then apply the other transformation to it. So for example, this green graph, I reflect it along the x-axis, and I notice that my black graph is just a vertical flip of my green graph. And in the same way, my the blue graph is a vertical flip of the red graph, and then a horizontal flip of the black graph. Now, what we can do here is we can actually go, okay, cool. I'm going to do one of the transformations first before I do the other one. So let's have a go at doing we can do one of the transformations first before we do the other one. So let's have a go here. Okay, I've got my f of x graph. I've got my original graph. I'm going to flip it along the x-axis first. So I'm going to go flip it along the x-axis. So here, my two x-intercepts are going to stay the same. I'm flipping along the x-axis, so I'm flipping it vertically. So instead of having a vertex at 1, negative 1, I'm going to have a vertex at 1, positive 1. So here, when I flip it first along the x-axis, I'm going to get this graph here. Okay, I've got that graph. Now that I've got that, I'm going to do another flip along the x-axis of my new blue graph. So here, to find my new graph, I'm going to flip it along the y-axis. So the first thing I'm going to notice is I've got my two x-intercepts at 0 and 2. My x-intercept at 0 is going to stay there. But my x-intercept at 2 is going to actually flip from positive 2 to negative 2. So I'm going to have a negative 2 graph. Flip. Now my vertex, it's still going to have a y value of 1. But instead of having an x value of positive 1, it's going to have an x value of negative 1. So here is negative 1. And so here, I'm going to get a graph that looks like this. And so this is y is equal to negative f of negative x. Now we can find the equation for that. That's fine. But here is how this is how we do that. So here is how we sketch our rotation about 180 degrees about the origin. So we've covered 3 graphical transformations here. What happens when we reflect our graph along the x-axis? What happens when we reflect our graph along the y-axis? And what happens when we rotate our graph at the origin by 180 degrees? Hopefully that was helpful. If you have any questions, feel free to ask me online. And as always, stay safe, stay healthy, stay wonderful, Year 11, and I'll see you next lesson.